Ionizing radiations refers to radiations that has enough energy to remove tightly bound electrons from atoms. So, if an atom is having a less electron, that it becomes one ion, because there is an imbalance between what, suppose this is a atom and this is nucleus, it is having some, suppose it is having two protons and it will have two electrons, and if your ionizing radiations will remove one electron outside, then it will become what, two proton and one electron. So there will be one resultant, what, resultant positive charge. So this will become one ion, it will become positive ions. So ionizing radiations are those radiations which can create ions by removal of tightly bound what, electrons. So in this video we will understand some examples of ionizing radiations, like X-rays. We utilize it for medical imaging, okay, and in X-ray radiography, CT scans, all these things we utilize X-rays. Then gamma rays. Gamma rays are highly energetic electromagnetic waves emitted by radioactive materials. They are used in radiation therapy for cancer treatment and different sterilization purposes. Okay, we utilize gamma rays for sterilization process. Then alpha particles. Alpha particles are positively charged particles composed of two protons and two neutrons. They are emitted by certain radioactive materials like radium and uranium. These are also some radioactive material, radium and uraniums, which are also utilized in nuclear power plant. Then beta particles. Beta particles are also high energy electrons or positrons emitted by certain radioactive isotopes. They can penetrate tissues and are used in nuclear medicine, imaging and therapy. Then neutron radiations. Neutrons are uncharged particles found in the nucleus of an atoms. We know this, there is in nucleus there is proton and neutron is generally having no any charge. They are neutrons. Neutrons radiations is produced in nuclear reactions and is used in neutron radiography and in nuclear reactors for power generations. Okay, so cosmic radiations, these are generally found in outer space and it is mainly having primarily protons and atomic nuclei, and it can pose health risks to astronauts and those who are traveling in high altitudes. Then ionizing radiation from nuclear decay. It's obvious when nuclear decay happens, there is emissions of some radiations. Okay, thoriums, uraniums, all these things are radioactive materials and they radiates. Radon gas, for example, can emit alpha particles and is a concern in indoor air quality. Okay, then particle accelerators. Particle accelerators like those used in research facilities can produce ionizing radiations when charged particles are accelerated to high energies and collide with target materials. So if in research process, if someone is utilizing one material which becomes highly charged and it can emit some electrons, so in that case some radiation can happen, and these are called accelerated particles. Then nuclear explosions. It's obvious when there is a nuclear bombings or explosion happens, there is emissions of radiations and which results in cancers and so much of genetic disease also it can creates. Okay, so high health effect is more. So it's important to note that exposure to ionizing radiation should be carefully monitored and controlled. So whenever we go to X-ray rooms, we should not see the x-rays, or we should not see the x-rays, because this is very harmful to eyes. It can cause cancer also. So ionizing radiation should be protect properly. It can damage the DNA and increase the risk of cancer also. Then safety measures are in place to protect workers and the public when dealing with ionizing radiation. Naturally, whenever we deal with sources of ionizing radiations, we need to be very careful because it is having some health hazards. So, thanks for watching.